This video is for 7.6 complex rational expressions. The objective to simplify a complex rational expression by simplifying the numerator and denominator separately. A complex rational expression is a fraction in which the numerator and/or the denominator contains the sum or difference of two or more rational expressions. So practice 1 is a complex rational expression where the numerator and denominator are single fractions themselves. And when we approach problems like this, we think of this just as division. We have the numerator as x squared over x squared minus 49. With this as the division bar, this is my numerator, and this is my denominator. So we divide by the denominator x over x minus 7. Now we just divide by multiplying by the reciprocal of x over x minus 7, which is x minus 7 over x. Now we simplify x squared times x minus 7, x minus 7, x plus 7 times x. So now we simplify the x minus 7's cancel, the x squared takes the x squared, leaves me with a 1 in the bottom and an x in the top. And finally, we're left with x over x plus 7. All right, so our goal with all of our rational expressions is to simplify the numerator and denominator so that they become single fractions, like practice 1, and then we divide. So in example 1, we have the sum of two fractions in the numerator. There's our numerator. There's our denominator. And we want to write these as single fractions in the numerator and denominator so that we can multiply by the reciprocal in order to divide. So step 1 is to take the numerator and write it as a single rational expression, 1/2 plus 2/5. Those dictate a denominator of 10. 2 goes into 10, 5. So we multiply this one top and bottom by 5. 2/5. 5 goes into 10 2 times. So we multiply this one top and bottom by 2, and we get 4. Now my numerator is a 9/10. So I go back and put that back in. And now we have 9/10 divided by 1 minus 2/5. 1 minus 2/5, that denominator is 5. So we multiply this top and bottom by 5. That gives us 5 on the numerator minus 2. And that gives us 3/5 then. So this now goes back in the bottom as 3/5. So step 3 is to rewrite it using those. And step 4 is to simplify by using the techniques for dividing. Multiply by the reciprocal. The numerator stays the same. The denominator, we take the reciprocal. Now we simplify that rational expression. Divide top and bottom by 3. Divide top and bottom by 5. And we're left with 3 over 2. Okay, so now we do it with variables. We take the numerator, which is 2 over x minus 3 over x squared. We're going to write this as a single rational expression. The LCD is x squared, so my first fraction needs an x top and bottom. That gives me 2x minus 3 over x squared. We put that back into the original problem. My numerator is 2x minus 3 over x squared. And then the denominator, step 2, is 2 minus 3 over x. We take that 2, multiply top and bottom by x to make them both have a denominator of x, and then we get 2x minus 3 divided by x. So that's my new denominator of the complex rational expression. Now we remember that that's divided by, which turns into multiplication by the reciprocal of that. That reciprocal is going to be x over 2x minus 3. 2x minus 3's cancel out, divide out, and then the x divides the x squared and gives us 1 over x. Example 3. We start with the numerator, a over 2 plus 4. This is 4 over 1, so their common denominator is a 2. The a over 2 already has it. The 4 needs a 2 top and bottom, so that gives us 8 over 2. Putting that back in as a plus 8, all divided by 2. My denominator, 2 minus a over 2. This is over 1. This needs a 2 top and bottom. 2 times 2 is 4 over 2 minus a over 2. So we have 4 minus a over 2. Put that back in. Now we take the division bar and multiply by the reciprocal. We keep the numerator unchanged, a plus 8 over 2, and then we have 2 over 4 minus a. In this example, the 2 divides the 2, and we're left with a plus 8 divided by 4 minus a. Here's your chance to practice. Take the numerator all by itself, 3 over y minus 1, make it a single fraction. Take the denominator, 9 over y minus y, make it a single fraction, put them back in, and then multiply by reciprocal and simplify. So I encourage you to press pause on your video, practice this, see what you get, and come back and watch the solution and see if it matches yours. Now that you've had a chance to work on that, I will work this out with you. 3 over y minus 1, their common denominator is a y. So I multiply the 1 by y over y. That numerator then becomes 3 minus y over y. Put that back in here as 3 minus y over y. 9 over y minus y. Their common denominator is also y. So this is over 1. I multiply it top and bottom by y to make it have that denominator. So we are left with 9 minus y squared. Now that we have our numerator and denominator as single fractions, we take the first numerator, 3 minus y over y, keep it the same, and multiply by the reciprocal of 9 minus y squared over y. That gives us y over 9 minus y squared. We have 3 minus y over y times y over 9 minus y squared is 3 minus y times 3 plus y. So the 3 minus y's, they divide each other out. They're the same, and the y's divide each other out. There's only a 1 left over in the top, so we get 1 over 3 plus y. Example 4. My numerator, 1 over 2 minus 1 over x. Need to make that a single fraction, and their denominator is, common denominator is 2x. 1/2 needs an x top and bottom, leaving with x over 2, and the x needs a 2 top and bottom, leaving me with x minus 2 over 2x. We place that back in the numerator, x minus 2 over 2x, divided by number 2. The bottom, 5 over x squared minus 5 over 4. Their denominator is 4x squared. The 5 over x squared needs a 4 top and bottom, and that leaves me with 20. The 5 over 4 needs an x squared top and bottom, leaving us with minus 5x squared. So we have 20 minus 5x squared divided by 4x squared. Now we take the division bar and multiply the numerator, x minus 2 over 2x, by the denominator, reciprocal of the denominator, 4x squared over 20 minus 5x squared. Now we factor and simplify. The numerator is 4x squared times x minus 2. The denominator has a 2x in it. And then we'll take out a 5, which leaves us with 4 minus x squared. That's a 10x. And 4 minus x squared is 2 minus x and 2 plus x. So what can we factor, or simplify, I should say? 2 goes into 4 2 times, and into 10, 5. The x takes the x from the x squared and leaves us with an x, and the 2 minus x and the x minus 2 are opposites of each other, so they leave a negative 1. Put the negative out in front, we're left with 2x on the top, and we're left with a 5 times a 2 plus x on the bottom. So the opposite of 2x over 5 times 2 plus x. Example 5. We take the numerator of our complex fraction, which is 5 over x minus 3, minus 2 over x. Their common denominator is x times x minus 3. So the 5 over x minus 3 needs an x top and bottom, and that leaves us with 5x. 2 over x has an x down there and needs an x minus 3 top and bottom. So we have 5x minus 2 times x minus 3. Now, as a single fraction, that's going to be 5x minus 2x plus 6 over x times x minus 3, which gives us 3x plus 6 over x times x minus 3. Put that guy back in there. Now my denominator is 2 over x minus 3 plus 1 over x. And their common denominator is x times x minus 3. So the 2 over x minus 3, we put an x top and bottom, 2x, and an x minus 3 top and bottom. So that gives us plus 1 times x minus 3. That gives us 3x minus 3 divided by x times x minus 3. Put that back in there. And now we take the numerator, 3x plus 6, divided by x times x minus 3, and multiply by the reciprocal of the denominator. Simplifying this, we do see the x and the x minus 3 canceling everything out there. The 3x plus 6 is 3 times x plus 2, and the 3x minus 3 is 3 times x minus 1. 3's cancel, and we're left with x plus 2 over x minus 1. All right, practice 2. This is your chance to see how you're doing. Please press pause on your video, work it out, get your solution, and come back and check it against my solution. Now that you've had a chance to work this out, I will work this out with you. My numerator is b over b plus 1 minus a 1. That tells me that the denominator is b plus 1, and my 1 over 1 now needs to have a b plus 1 multiplied top and bottom. When you have a minus sign separating the two terms, be very careful. you need to distribute it and the b's cancel. We have -1 over b plus 1. So I keep track of that piece. Goes back in here as a -1 over b plus 1. My denominator is b plus 3 over b minus 2 over 1. Our common denominator there is a b, so this needs a b top and bottom. 2b. So we'll have b plus 3 minus 2b, all divided by b. b minus 2b is -b plus 3, all divided by b. All right, so we have -b plus 3, all divided by b. And now we take the first fraction, -1, over b plus 1, and multiply by the reciprocal, b over -b plus 3. And there's nothing that can simplify here, so you get -b times b plus 1 times -b plus 3. That's a valid answer. You could write the -b plus 3 as 3 minus b, or what some people do is take this minus sign and distribute it through on those two pieces and make it b over b plus 1 times b minus 3. However, all of these answers are equally good for us. All right, so that concludes this video on 7.6 complex rational expressions.